Hello everyone. Today we are going to discuss electrophilic or nucleophilic substitutions and addition or elimination reactions. Let's discuss addition reaction. Do you know what is addition reaction? A reaction in which atoms or molecules are taken up by a multiple bond is described as addition reaction. Alkenes, having double bond between carbon atoms, react with hydrogen halides to form alkyl halides. Halides mean fluorine, chlorine, bromine, iodine. Ethene reacts with hydrogen chloride. So product will be formed by addition reaction. This addition reaction takes place in two steps. Let's discuss its mechanism. Ethene and hydrochloride react. Ethene accepts the proton of hydrogen chloride to form a carbonium ion, and chloride ion will also be formed. This carbonium ion then reacts with the chloride ion, which is then added in structure. The converse of addition means the removal of groups with the formation of a double bond is termed as elimination. For example, butanol, as OH group is present in the presence of sulfuric acid and heat, this OH group and hydrogen in butanol will be eliminated as a water and butene will be formed. Let's discuss the mechanism of this reaction. This is butanol that reacts with sulfuric acid. The alcohol is protonated by the acid catalyst. The protonated alcohol loses a water molecule. One hydrogen is also lost by it, and it is taken away with hydrogen sulfate that was formed from acid catalyst after losing hydrogen. Double bond will be developed in the structure, so butene will be formed, along with water and sulfuric acid. Another type of reaction is the electrophilic substitution. Electro means electron and philic means loving. So, it is electron-loving. In other words, it should be attracted towards electron-rich species. Let's understand this. Electrophilic attack on pi bond of benzene to form carbonium, then base attacks on hydrogen of aromatic ring and takes this hydrogen away with it. Thus, electrophile is substituted in the ring. For example, in halogenation of benzene ring means addition of a halogen, like chlorine. Benzene reacts with chlorine in the presence of a catalyst like ferric chloride. But what's the mechanism of this electrophilic substitution? The actual halogenating agent is Cl+. It is formed when chlorine and catalyst react. A strong electrophile and tetrachloroferrate will be formed. This electrophile then attacks to benzene ring. Carbonium will be formed. Hydrogen donates its electrons to benzene ring and move out as it lost electrons. So it becomes positively charged and chlorobenzene will also be formed. This hydrogen ion then reacts with previously formed tetrachloroferrate, so hydrogen chloride and ferric chloride will be formed. Ferric chloride, which was a catalyst used in reaction, as catalyst only facilitate the reaction. And in this reaction, ferric chloride as a catalyst helps to make a stronger electrophile. Few examples of electrophiles are chlorine, bromine, and nitric acid. Moving to nucleophilic substitution reaction. Nucleo means nucleus and philic means loving. It has an unshared electron pair available for bonding, and in most cases, it is basic in character. It may be negatively charged or neutral. Let's understand its mechanism. When nucleophile attacks, substrate molecule, bond with leaving group breaks, and leaving group will be moved out, so leaving group departs its unshared pair of electrons, and nucleophile is substituted. Now, what is L? L is also a nucleophile. It is called leaving group because it departs with an unshared pair of electrons. For example, this is hydroxide and this is bromoethane. When hydroxide ion, which is a nucleophile, attacks bromoethane, which is a substrate molecule, a transition state will develop. Leaving group will depart its unshared pair of electrons. Methanol, as a product, will be formed and leaving group moves out. This table contains few examples of nucleophiles, such as hydroxide ion, ethoxide ion, hydrogen sulfide ion, and amino group. That was all about today's video on substitutions and addition or elimination reactions. Stay tuned to sqadia.com for more precise and knowledge stuff videos.